Hi everyone. In the last lecture we have discussed about basics of mechanics, engineering mechanics. And in today's lecture let us see what is equilibrium and what is free body diagram. What is equilibrium? Equilibrium can be stated in two types: coplanar concurrent, when coplanar concurrent forces acts, and coplanar non-concurrent forces acts on a body. If concurrent forces acts on a body, then it is called as coplanar concurrent equilibrium. For this, a body to be in equilibrium, there is a condition if concurrent forces acts on a body. That condition is sigma fx is equal to 0 and sigma fy is equal to 0, which means a body is said to be in coplanar concurrent equilibrium if its state of rest or uniform motion in a straight line does not change. What this definition is saying is, if there is a body and concurrent forces are acting on this, and this body is at rest. Even the forces are acting on this body, the body is at rest, then it is said to be in equilibrium. If a body is in motion, uniform motion in a straight line, if this body is moving with a uniform velocity v and some other forces are acting on this, like this, these three forces acting on this body are not affecting the velocity v, then this type of system is also said to be in equilibrium in motion, and this is equilibrium in rest. So this is the condition for the body to be equilibrium under the action of concurrent forces, and these forces should be in the same plane. So this is called coplanar concurrent equilibrium. And the next one is, let us see what is free body diagram, and we refer free body diagram for coplanar concurrent forces. A free body diagram is a diagram which is drawn by choosing a body or particle in the system free from all other bodies. If there are two bodies in a system and we need to draw free body diagram of one body, then we should draw free diagram of that selected body excluding the other body. What are the steps to draw free body diagram? If there are a number of bodies in a system, then consider the one body which is to be drawn as free body diagram and represent all applied forces. What are applied forces? If there is a ball like this, there is a ball and it has self weight, let us represent it with W, and a force acting on this. Due to this, the surface produces a reaction R and it is in equilibrium, then this is called free body diagram. Okay. The actual diagram is called space diagram. space diagram. What is space diagram? Suppose there is a rock on the ground. A man is sitting on the rock. This is the space diagram. What is free body diagram? Free body diagram is step 1 to draw free body diagram is consider and draw the free body diagram. Let us consider this rock as the body. This rock is body, and represent applied forces, self weight and reactions from other bodies in contact. So suppose weight of this person is 600 newtons and weight of this rock is 1000 newtons. Then what are the external forces acting on this body? This body has a force of this guy who is 600 newton weight, 600 newtons, and this rock has self weight of 1000 newtons, and this surface is exerting a reaction of R. If this rock is in equilibrium, then we can if the rock is in equilibrium, then we know sigma fx is equal to 0 and sigma fy is equal to 0, which means sum of horizontal component of forces and vertical component forces should be 0. In this there are no any inclined forces, so all are vertical forces. So considering downward direction as negative and upward direction as positive forces, minus 600 minus 1000 plus R is equal to 0. This is sigma Fy is 0. Then R is equal to 1600 newtons. This is the reaction exerted by the floor onto the rock. This is the free body diagram. Let us see some examples of free body diagram. Just now seen example is this one. This has free body diagram like this. W. This is reaction R. And next another one. There is a wall. And free body diagram for this is the wall, and the reaction, it is lying on this wall, so there exists a reaction R, and this is the wire, so there exists tension T, and the self weight of the ball, which is W. These three are concurrent forces. And next example is there is a ladder laid to the wall. This is the floor, this is the wall, and there is a force to stop this ladder from slipping down, and there is a man standing on ladder who is 600 newtons. So in order to draw the free body diagram, let us consider the body as ladder. This is the body, and the forces acting on this ladder are a man with weight 600 newtons, self weight of the ladder, which acts at this point, center of gravity of ladder, and there are reactions, and also a force P is acting to stop the slippage of ladder. The vertical reaction will be acting at the floor, let us say it is R1, and also as the weight of the ladder and weight of the person has impact at this wall, so there is a reaction from the wall onto the ladder which is horizontal. Suppose this is R2. This is the free body diagram of this ladder. And another type is there is a pulley, this is a pulley, a weight of 600 Newton is resting on the floor, and 400 Newton is in the air. Then the free body diagram for this is, there are two bodies in this. First we should select one body for which free body diagram is to be drawn. If you select 600 Newton body, this is the body, and what are the forces acting on it? There is a tension T which is upwards, and there is weight 600 newtons downwards, and there is also reaction R from the floor. If you consider 400 Newton this body, there is a tension T upwards and 400 Newton downward force. There is no reaction because nothing is stopping this 400 Newton body, but in 600 Newton case the floor is stopping the body from coming down, so there is a reaction. in 400 Newton body there is no reaction. Let us solve some examples based on these free body diagrams. These free body diagrams are very important because in mechanics, every problem given in mechanics shall be drawn with the help of free body diagram only. See, there is a question here. There is a ball attached to a string which is fixed to this wall here. So it is said to us calculate the tension in the wire and the reaction of the wall on the ball. First we need to draw the free body diagram of this problem. If we consider this as the body, this is the body, and what are the forces acting on it? There is tension T, and another one is weight acting downwards, and this weight is 100 newtons, and another one is reaction from the wall on the ball. And this is R, this is T. This is the free body diagram for this figure. So now we have drawn the free body diagram. If there are three forces, we can solve this by Lamis theorem. We have seen in last class that what is Lamis theorem. What is Lamis theorem? If there are three concurrent forces acting, then the forces are directly proportional to sine of angle between other two forces. Let us plot this diagram. Let us plot these forces into Lamis theorem. Let me take another color. I can place this force here because due to transmissibility of forces law, I can place this force here which is in the same line of action. Then the forces can be drawn like this. This is R, this is W, and this is T. Okay. Let us say this angle is here, it is given 15 degrees, which means this is 15, and this also becomes 15 degrees because alternative angles are equal between parallel lines when there is a transversal. So this angle is 15 degrees. And this is 90 degrees, this is 90 degrees, this is 90, and this becomes total 90 minus 15, which is 75 degrees. If we solve this, what is Lamis theorem states? R by sine of 90 plus 75 90 plus 75 is equal to, next is t by 90, t by sine 90 is equal to w by sine 90 plus 15, 90 plus 15. So what are the quantities we know? We know this w is 100 newtons. So to find r is equal to 100 into, by considering these two, 100 sine 90 plus 75 is 165 divided by sine of 90 plus 15 is 105. Then the value of r is 26.8 newtons. If we consider these two, we will get tension in the wire. T is equal to 100 sine 90 divided by sine 105. T is equal to 103.5 newtons. These are the answers, T and R. Next problem. Calculate the reactions of surfaces on the ball. There is a ball which is lying on the two walls, and the weight of the ball is 400 newtons. This angle is 60 degrees and this is 45 degrees. The reaction always acts at angle perpendicular to the surface. This is reaction, and this is another reaction by the surfaces. So these are the reactions. Let us calculate the angles. As this is 60 degrees, this will be 60 degrees. This is 90 degrees. So this will be 90 plus 60 is 150 degrees. 180 minus 150 will be 30 degrees. This is 30 degrees. So, because sum of angles in a triangle is 180 degrees. By considering this, if you consider this is 45 and this will also be 45 degrees, and this is 90. So 90 plus 45 is 135 degrees, and this will be 45 degrees. 180 minus 135 is 45 degrees. We have got the angles. And now let us draw the free body diagram of this ball. The free body diagram of this ball, how it will be. This is the ball, and what are the forces acting on it? One is weight, and the reactions. Let us say this is R1, this is R2, and this is weight W. If I plot these forces like this is W, and I transfer this force to here. This is R2, and I transfer this to here. This is R1. And now what are the angles? This will be 45 degrees, this will be 30 degrees, this is 90, this is 90 degrees, and this is 180 minus of 45 plus 30, which is 105 degrees. This is like Lamis theorem. We can apply Lamis theorem for this figure. So what are the forces? W divided by sine 105 is equal to R1 divided by sine of 90 plus 45 another one is R2 divided by sine of 90 plus 30. So we need to find the reactions, right? R1 is equal to, what is W? Weight of the ball. Weight of the ball is 400 newtons. Considering these two, R1 is 400 into sine 135 divided by sine 105, which is R1 is equal to 292.8 newtons. And if you consider these two, R2 is equal to 400 sine 120 divided by sine 105 degrees. Then R2 is 358.6 newtons. This is how we will solve this problem. First we need to draw the free body diagram, and we should apply the respective method. If three forces are there, then Lamis theorem should be applied. And another problem, let us see. So these are two buildings. This is one building, and this is another building. First there is a block placed on the floor, and when the truck approached here, they are lifting. One is lifting here and another one is pulling here, so that this block is lifted and to be placed on the bank. So this is the space diagram, what we call this space diagram. Space diagram. In order to select a body, let us select this body to draw the free body diagram. How it becomes? The weight it is given that this is 736 newtons, which means it is acting downwards. (736 newtons), and another, this is a wire and this is another wire. Tension PAB, and this is TAC, this is 50 degrees, this is 30 degrees, this is 50 and this is 30 degrees. So this is also in the form of Lamis theorem. We can solve this in using Lamis theorem. This is 90 degrees, this is 90 degrees, and this will be 50 plus 30 is 80, 180 minus 80 is 100 degrees. 100 degrees. And if we apply Lamis theorem here, Lamis theorem, what are the forces? TAB divided by, what is this, sine of 90 plus 30 is equal to, another force is TAC divided by sine of, opposite angles are 50 and 90, 90 plus 50, and another is force 736, which is weight of the block, divided by sine, opposite angle is 100 degrees, sine 100. If we consider these two, TAB becomes, TAB is equal to 736 sine 90 plus 30 is 120 divided by sine 100, which is equal to, TAB is equal to 647.23 newtons, and if you consider these two, TAC is equal to 736 into sine 90 plus 50 is 140 divided by sine 100, which is TAC is equal to 480.39 newtons. Okay. This is how we solve this practical problem. And next is this is very important problem, which has also appeared in GATE once. There is a roller here this is the roller, and a force is applied at point B so that it just crosses over this curve. This is called curve. A force is applied at point B so that it just lifts over the curve. What are the parameters, dimensions given here? The radius of the ball is 300 mm, and this height of the curve is 150 mm, and weight of the ball is 2000 newtons. He is asking to find force F just to lift the ball. What is the force required, and also what is the minimum force required to lift the ball over the curve when applied at center of the ball. First question is, what is the force required if we apply force at point B? Second question is, what is the minimum force required if we apply force at this center of the ball? Let us find out. Let us say this is A. First we need to draw a free body diagram, whatever the question may. By considering this ball, the free body diagram becomes like this. This is the ball. What are the forces acting? This is force F. And there is Newton, weight of the ball, and as the force is acting in this direction, there will be a reaction which is concurrent to these both forces. This is weight, this is reaction. So these three forces should be concurrent. Reaction acts in a direction such that it meets at this point B. So reaction will be like this. This is reaction. This is point A, this is point B, this center is point O, and let us suppose this is point C. And if I draw a line like this, in order to find this problem using Lamis theorem, we need to know this angle. In order to find that angle, suppose this is beta, this is alpha, this is 90 degrees, and what will be this angle? Let us see. Let us take cos alpha. What is cos alpha? Alpha is this here. Adjacent divided by hypotenuse is cos. What is the adjacent side of alpha? It is OC. OC divided by hypotenuse is OA. OC divided by OA. Cos alpha is equal to, what is OC? We know that the radius is 300, and the curb height, this curb height is 150. So distance from center to here will be 150, right? Then OC is 150 divided by OA. What is OA? It is the radius, which is 300, which is 1 by 2. Alpha is cos inverse 1 by 2, which is 60 degrees. If alpha is 60 degrees and this is 90 degrees, this will be 30 degrees. This is 30, this is 90, and alpha is 60. We have found out this angles in this small triangle OAC. And if we consider triangle OAB, if we consider triangle OAB, in triangle OAB, OA is equal to OB. We know that if two sides are equal in a triangle, then the angle opposite to those sides will also be equal, which means angle opposite to side OA, this is radius. Angle opposite to OA is angle OBA. Angle OBA, which is equal to angle opposite to OB is angle opposite to OB. It is angle OAB. Angle OAB. Right. And also alpha plus beta. What is alpha plus beta? Or if we consider this same triangle, angle OAB plus angle OBA plus beta is equal to 180 degrees, because sum of angles in a triangle is 180 degrees. But alpha plus beta is equal to 180 degrees. Since this is a straight line, alpha plus beta is 180 degrees. Then beta is 180 minus alpha. By substituting this value in this, angle OAB plus angle OBA plus 180 minus alpha is equal to 180. Is equal to 180. 180 gets cancelled, and alpha is equal to angle OAB is equal to angle OBA. So you can write 2 into angle OBA, right? Angle OBA, we need this. Angle OBA is equal to alpha by 2. What is alpha? Alpha we got here, it is 60 degrees. So 60 by 2 is 30 degrees. 30 degrees is angle OBA. If we form as a Lamis theorem problem, considering this point B, this is force F, which is to be pulled with, and by law of transmission R can be drawn like this. So this is reaction, and another one is 2000 newtons. Okay. Here we got angle OBA as 30 degrees. If this is 30, this angle will be 60 degrees. Okay, which means with this is 30 and this will be also 30 because angle OBA is equal to angle OAB. This will be 30. Okay. So this makes an angle 60 degrees, this is 90 degrees, and this is 180 minus 60, 120 degrees, and this is again 90 degrees. So by Lamis theorem, R divided by sine 90 is equal to another force is F divided by sine 90 plus 60 is equal to another force is weight, which is 2000 newtons, divided by sine 120. So R is equal to, if we consider these two, R is calculated as 2309.4 newtons and F is calculated as 1154.7 newtons. By this we have completed the first question. And the second one is, if any force is applied at the center of the ball, then what will be the minimum force to lift over the curve? Let us find it now. I'll draw the diagram here. This is the center. Suppose there is a force F, which is acting at an angle theta to the horizontal, and there is reaction R which passes through the center, and there is weight 2000 newtons. This is R. And what are the angles? How to find the angle theta? Angle theta is there. This is 150. This is 300, which is radius. So this angle will be, this is 150, this is 150, and this is 300. This will be 300. So 150 by 300 sine inverse of opposite side is 150 divided by 300, which will be 1 by 2. Sine inverse of 1 by 2 is 30 degrees. 30 degrees. This is 30, this is 90, and this will become 60. So let us find the angle theta now. From law of equilibrium we know that horizontal and vertical components of the forces should be 0. Sum of the horizontal and vertical components. So sigma FH is equal to 0, which means what are the horizontal component of all the forces? F cos 60 cos theta, which is this is F, and the horizontal component of this force is this one. This is theta, so cos theta is equal to opposite side, which is Fy divided by horizontal component, divided by hypotenuse, which is F. This cos theta is adjacent side, right? This is X, horizontal component. Then Fx is equal to F into cos theta. So F cos theta is in this direction, and the component of Rx is, this is 30 degrees, and it will be minus R sine 60. This is 30, this is 60, right? This is 60. If you consider this angle, then it will be R sine 60. And another force is 2000, which is vertical, and horizontal component of this 2000 Newton is 0. So this is 0. Therefore F cos theta is equal to R sine 60, right? And if you consider vertical components of force, this is Fy, and this is Ry. If you consider vertical components, sigma Fv is equal to 0. Sigma Fv 0 is first vertical component of F. F has, if consider this angle theta sine theta is equal to opposite side is vertical component Fy divided by hypotenuse F, which means Fy is equal to F sine theta. F sine theta is vertical component of force F, and reaction R. If you consider this is also reaction R vertical component, this one. If you consider this angle, this will be in terms of cos, plus considering 60 degrees, R cos 60 minus W is equal to 0. But R is equal to F cos theta divided by sin 60 if we take this here. So F sin theta plus R is F cos theta divided by sin 60 and this cos 60 minus W is equal to 0. If we take common F here, F into sin theta plus cos theta by cos 60 divided by sin 60 is cot 60 and this cos theta, this W is sent here, W. So sin theta plus cot 60 cos theta is equal to W by F. So to be F to be least, this to be least, the value of W by F should be large. F to be least, W by F should be large. So when does maximum value reaches? In order to find the maximum value, we know we should differentiate it. So d by d theta with respect to theta, if we differentiate, W by F is equal to 0. What is W by F? D by d theta of cos theta, sin theta plus cot 60 cos theta is equal to 0. If we differentiate with respect to theta, differentiation of sin theta is cos theta plus cot 60 is constant, cot 60. If we differentiate cos theta, it is minus sin theta equal to 0. Then cos theta is equal to cot 60 sin theta. If we send sin theta here, cos theta divided by sin theta is equal to cot 60, which means cot theta is equal to cot 60, theta is equal to 60 degrees. We have got the angle theta is equal to 60 degrees to be W by F to be maximum. So if W by F is maximum, then F is minimum. If we substitute this theta angle in this equation, then it becomes sin 60 plus cot 60 into cos 60 is equal to, what is W? The weight 2000 divided by force F, which is to be pulled. If we calculate this, F will be 1732 newtons. This is the minimum force required when applied at the center of the block. Minimum force required for the ball to climb the curb when applied at center of the ball. Right. Till now we have seen if concurrent forces are acting on a body, then what is the equilibrium? If non-concurrent forces are acting on a body, then what will be the definition of equilibrium? In concurrent forces, we have seen that there should be no change in rest, or which means if a body is in rest, it should not move. If a body is in uniform motion, it should not accelerate or something. In non-concurrent equilibrium, the body should not translate and the body should not rotate, which means translatory and rotationary movements are restricted when non-concurrent forces are acting. So the condition for non-concurrent equilibrium, which means equilibrium when non-concurrent forces are acting, is sigma fx is equal to 0, sigma fy is equal to 0. This is for translationary moment restriction, and sigma m is equal to 0, which means moment about a point, sum of moment about a point made by all the non-concurrent forces should be equal to 0. This is restriction of rotation moment, this is restriction of translation moment, so that the body remains in equilibrium. Let us consider this example. There is a ladder laid against the wall, and it is resting on the ground. These two surfaces are smooth, which means there is no friction. Two surfaces are smooth. He is asking us to find what force should be applied here. What force should be applied here so that this guy standing on the ladder remains in equilibrium and this ladder does not fall down. And he is also asking to find reaction developed by floor and the reaction developed by wall on the ladder. Let us find it. And the weight of the ladder is 100 Newton. Weight of this guy is 700 Newton. And the height from the floor to the guy standing on the ladder is 2 meters. This total height where ladder is placed is 3 meters. The angle between the ladder and the floor is 60 degrees. This is the given data. If we draw the free body diagram by considering this ladder as a body, this is the ladder. This is force F. And the reaction developed by floor on the ladder is, suppose, RA. This is RB. This is 60 degrees. 60 degrees. And this height is 3 meters. And this guy standing here, 700 newtons. This height is 2 meters. The center of gravity lies here, which is half the distance, half the height of the ladder placement, which means this will be 1.5 meters. This is center of gravity where the weight acts. What is weight of the ladder? Weight of the ladder is 100 newtons. This is the free body diagram. If you see here, these all forces are non-concurrent forces. R, A and F are concurrent, and the weight and these two does not coincide at any point, and these two does not coincide, and RB does not coincide with any one of these. So these are non-concurrent forces. We need to solve this by three equations. Sigma m, suppose this is the point A, this is the point B. If we take moments about point A is equal to 0. What are the forces about point A? This R, A and F, these are passing through point A, so there is no moment created by these two forces about point A. Other forces are weight. Considering clockwise as positive, anti-clockwise as negative moment. So what are the forces? Suppose this is horizontal one minus RB, because this force is trying to turn the ladder in anti-clockwise direction. This is anti-clockwise direction, right? RB is trying to turn the ladder in anti-clockwise direction with respect to A. So anti-clockwise is negative minus RB. What is the distance between, perpendicular distance between point A and force of action RB? It is 3 meters. And next force is 700 newtons. 700 Newton is acting downwards, and which tries to turn the ladder in clockwise direction, which means positive 700 into this distance is this is 2 meters. It will be, which will be 2 cot 60, because distance from this point to this point is 2 meters, right? This is 2 meters. And cot is the relation between, what is cot theta? Cot theta is adjacent side by opposite side, which means this side by this one, this side by this total one, which is cot 60. Cot 60 is this by this, which means this is 2. This is to be known. I'll write here cot 60 is equal to, let us say this is point C, AC divided by 2. AC is equal to 2 cot 60. Cot 60. AC is 2 cot 60. That's why here it is 2 cot 60. And another force is weight. Weight is 100 newtons into what is the distance between this point and this point? It will be 1.5 cot 60. Same as this, calculation of this distance should be carried out. This is 1.5 cot 60, which is 0. If you simplify this, RB has a value of 298.3 newtons. This is moment 1. And another formula and another condition for equilibrium is horizontal component forces should be equal to 0, which means F minus RB is equal to 0. F is equal to RB, which is 298.3 newtons. How this has come? Horizontal component of forces are, this is horizontal and another horizontal is this. These two are vertical, right? Only horizontal forces are this and this. So F minus RB is 0 and F is equal to RB. This is the answer. By this, free body diagram and equilibrium has been completed. Let us see the summary. First, equilibrium can be of two types: coplanar concurrent and coplanar non-concurrent, which means if a body is acting with concurrent forces, then it is said to be in equilibrium if the state of rest or uniform motion does not change. State of rest or uniform motion does not change, then it is said to be concurrent equilibrium. In non-concurrent equilibrium, there should be no translation and no rotational movement. What is a free body diagram? Free body diagram is a diagram drawn considering a body and free from all bodies, and we have to represent all the forces and self-weight and the reaction from other bodies in the system. And these are the problems related to all equilibrium. If three forces are used, if three forces are there in a system, then Lamis theorem is to be used. And if more than three forces are there, then sigma fx is equal to 0, sigma fy is equal to 0 should be used. That's it. If you like this video, please share this video in your groups to your friends and subscribe this channel so that you cannot miss any other videos uploaded in this channel. Thank you.